Okay, good morning. So we are all set. And first of all, let me introduce my teaching assistant and yours at the same time. Yours, Hiba Said. So she may want to give you her coordinates so that you know how to reach her, or at least tell you where to find her coordinates.
Sure, I would just like that.
Okay. Thank you. So now you know where to turn to reach her. So, as far as I'm concerned, last time I had left the slot regarding my own office hours blank, but now I have decided about it. So, my office hours will be also on Tuesdays and on Thursdays. Between 10 and 11:30, but I will also update the course outline with this information. So if you forget, you can always find the information in the course outline. So today is going to be, thank you. Today is going to be a very important lecture because we are going to lay the foundations of the ISLM model, at least to recall, because we should already have done that in previous course, but to recall the foundations of the ISLM model. First of all, deriving the IS curve. Second, learning the reasons why it could shift around. And then doing the same with respect to the LM curve. So it's a really important point. So please follow carefully. So what we will be doing first is to derive the IS curve in two ways. Number one, we will be using the Keynesian cross. Now the Keynesian cross uses the equality between planned expenditures and actual expenditures. So since all the analysis we'll be doing here is basically graphical, it's based on graphs, so we need to put on this graph first planned expenditures and then actual expenditures. So here we have output on the horizontal axis and planned expenditures on the vertical axis. And this line, you see the blue line, is our planned expenditure. So the three components of planned expenditures are consumption, investment, and government purchases, G. Now, consumption is a function of disposable income, after-tax income, which is Y minus T, which is taxes. Okay, investment, in this preliminary version from chapter 10 of MindQ, is exogenous, but generally investment, we immediately change that into making it a function of the interest rate. It's a negative function of the interest rate because the interest rate is a cost when you are looking for funds to invest. Okay, so that's investment, and government expenditure is generally considered an exogenous policy variable, which is decided by governments. Now this line would start somewhere on the vertical axis, which means that even when there is zero income, there is already some planned expenditure, and then it would have a slope which is less than 1. And the meaning of that slope is the marginal propensity to consume. And the reason why it is less than 1 is because we generally do not consume everything we earn, all our income, but we consume a fraction of it and the rest we save. So the marginal propensity to consume is what we consume of $1 of after-tax income, and then 1 minus the marginal propensity to consume is what we save of that dollar we earned. Okay? So that's the planned expenditure line. Now the other line is actual expenditure. Actual expenditures is basically the 45-degree line. It's the line it's the line which equates the values on the horizontal axis with the values on the vertical axis. So it is basically the line which makes expenditure equal to income or output. Okay? That's the 45-degree line. Now, where the 45-degree line meets the planned expenditure line, that's where actual expenditure is equal to planned expenditure. Okay? So that's the equality y equal c plus I plus g. And that's the equilibrium. So this will be the equilibrium income. Okay? And this will be the corresponding expenditure, which is the same value, given that it is on the 45-degree line. Okay? If you have any question, please ask anytime. Do not worry about stopping me. Just ask any question you may have in your mind. Now, what happens if we are not where the two lines meet? For example, if we are at income Y1. At income Y1, you can see actual expenditure is higher than planned expenditure. So that means that more is being produced than what it is actually required. So there is an inventory accumulation. So because of that inventory accumulation, production will be reduced, firms will start producing less because they see inventory accumulating. So Y will drop down towards equilibrium income. Similarly, if we are at a lower level than the equilibrium, at Y2, then actual expenditure is less than planned expenditure, and so firms will see their inventories drop. So they will naturally want to increase production, and therefore we will see income increase towards the equilibrium. So either way, there is a natural tendency for income to move towards equilibrium, okay, if it is not there already. Now, this is our Keynesian cross, right? So from here, we want to derive the IS curve. How do we derive the IS curve from here? This is a planned expenditure line which is drawn, expenditure is equal to C, which is a function of disposable income, plus I, which is a function of R, plus G, which is exogenous. So this is a positive function of disposable income, whereas investment is a negative function of the interest rate. So how do we, and then of course we have Y equal E. So how do we derive the IS curve from here? So any given line, for example, this line, will be drawn for some given interest rate value, right? At that interest rate, you have that given level of investment, and you have that line, okay? Correspondingly to that, there will be an equilibrium level of income. It's Y1. So how do we continue from there? Yes?
We can change R and see how that affects our planned expenditure.
Okay, so we need to change R, for example, to a higher level, R2. Okay? And that will, so here is what we do. First, this is our investment function. This is investment on the horizontal axis. This is the interest rate. It's a negative function of the interest rate. So higher the interest rate, lower is the level of investment. So we start from R1 and we get this matched level of investment. Okay? Now we increase R to R2. So looking at the investment function, we know that the investment level drops. Okay? So this is reflected here. Because investment has dropped, the planned expenditure line will move down. Okay? It moves down. And the amount of the shift is exactly the change in investment. So at the original level of income, there is now an unwanted accumulation of inventory. So because of what I said before, income will drop to Y2. Okay? So all we need to do now is to report these values on the graph with income output on the horizontal axis and interest rate on the vertical axis. So the original pair was Y1, R1. Now that we have moved to R2, our income has gone down to Y2. So we have 2 points. And then we can connect them with a line, and that's our IS curve. Okay? And it is downward sloping. It is downward sloping because when the goods market is in equilibrium, with higher interest rates, we need lower level of income to keep it in equilibrium. Okay? So this is one way of deriving the IS curve. There is another way, and this other way uses the, so we started with this equality, okay? We started with equality between actual expenditure and planned expenditure. But if we move consumption and government purchases on this side, what we have here, this is income minus private plus public expenditure, plus public consumption. So that's another way of, what is another way of calling this? Savings. Okay, this is savings. So an equality equivalent to actual expenditure equal planned expenditure is savings equal investment. Okay? So we use this other equality here. So we have a graph with savings and investment on the horizontal axis, and we have another graph, an interest rate on the vertical axis. Now, so we know that investment is downward sloping, we just discussed it. Why would savings be upward sloping? The higher the interest rate, the more we get when we save. So the more we will want to save. Okay? So that's why it is upward sloping. And these saving curves are drawn for a particular level of income. So if income is higher at each level of interest rate, we want to save more. If we have more, we see more money coming, naturally we will save more. So for a higher level of income, the saving line shifts to the right. Okay? Now, if we start here at this level of interest rate, okay, we have an equilibrium between savings and investment. Consider this graph of savings and investment as a graph describing the market for a good. The good is here, it's, funds, loanable funds. So, on one hand, we have the demand for these funds, which is the investment curve. And on the other hand, we have the supply, which is the savings curve. So here, the interest rate is the price of this good. Okay, so when we increase the level of income, so first of all, we have a particular interest rate, 7%, for example, and particular level of income. So we report that here on the highest graph. Now, if we increase the interest rate, if we increase the level of income, this line will shift, as I said. Okay? So when it shifts, at the original interest rate, what do we have? What do you see on the graph?
7%.
At the original level, 7%. What is the situation in the market?
So the supply is shifting to right.
Excess
Supply.
excess supply of funds. We have more people wanting to save than people wanting to invest. So people will, at this interest rate, will want to invest this much, but they are going to save this much. So there is an excess supply of funds, right? So what happens in any market when you have an excess supply? The price falls, because those supplying the good would be willing to accept a lower price, okay? So we move to this point with lower interest rate. Did you understand this mechanism, how we move towards equilibrium? Okay, so we move to 5%, which is the new equilibrium, and so we have lower interest rate, but higher income. We report that here, and then we connect the dots, and we have the highest curve. It is always important to connect the dots, as somebody famously said. So, this is how we derive the highest curve from this graph. So notice how we have done it two ways. In the previous case, we did it by changing the interest rate and then seeing how income was reacting to that. Here, we do the opposite. We change income and we see how the interest rate reacts to that. Okay. So here, we can see why the highest curve will have a downward sloping slope. It will be characterized by a downward sloping line. Why? Because when the income increases, so people want to save more, so to preserve that equality between savings and investment, since with higher income people will want to save more, we need something to bring investments also to that level, and that will be a lower interest rate. Okay? So that's why we have the need to keep the market in equilibrium, the need whenever income goes higher for interest rate to drop. Okay? Is this clear? Sometimes I see the head saying yes, but the eyes are not saying the same thing. Is it clear?
One thing, in the case of the highest curve, output is equals to income.
Yes.
Is income.
Output and income are equivalent terms, synonymous terms. Yeah. Okay, now let's see why would the highest curve shift around. Okay, so this is a very important point where people sometimes make a lot of confusion. So whenever we are seeing changes in the two variables that are on the axis, which are the level of output or income and the interest rate, then that means we are moving along this curve. So this curve is drawn to show the changes in one variable when we change the other, naturally. And then there are other variables which are exogenous to this story, like government expenditure. So when we change these other variables, then we change curve. Then the curve will shift. Okay, so here, now, we are considering a change in G, government expenditures. So this will be a case where the highest curve is going to shift. We are no longer staying on the same curve because what is changing is not one of these two variables, but it's a third one. Okay? So that's why we are changing the curve. So we start here, again, with the Keynesian cross. I'll show the same thing also with the other graph, but let's stick with the Keynesian cross. So here we see this planned expenditure is for this interest rate and for this government expenditures. Okay, now, if we increase G, so we have a corresponding level of income, and we plot it here. Now, if we increase G, okay, then we have a higher planned expenditure line. It moves up. Okay. It moves up, and that will move the level of income up to the equilibrium income up to Y2. Now, what is different than before? Why are we changing curve? You can see. Because the level of interest rate is still the same. It's not changed. So we are still at the same level of interest rate, but now we have a higher level of income. So that's why we are on a different curve. Okay? So this is one thing which is important. The second one is that the original shift in the planned expenditure line, this shift is equal to how much?
G2 minus G1.
Yeah, so delta G, right? Delta G is that vertical shift. What about the delta Y? Is that equal to delta G? Yes or no?
No, sir.
Who is for yes, who is for no? Yes? Hands up. One yes. How many no? I'm afraid that the majority wins.
So government spending would have a higher effect in the net income input by the government.
Why would that be? Why would the increase in G result in a higher, more than proportional increase in Y?
Multiplier?
Yeah, but why? What is that work there?
Oh, so if the government puts in, let's say, $100 into the economy by government spending, then people will spend those $100 and then they will spend that again and then spend it over and over again depending on the...
Yeah, the key thing is here. Consumption is also a function of income. So when government expenditure makes income go up, then when government expenditure makes income go up, then consumption will go up also because it's a function of income. And that will in turn increase income further. And so you have a cycle where the original increase in G increases income, which increases consumption, which increases income, which increases consumption, and so on. And therefore there is a multiplier effect. Okay? That's why this delta Y is greater than delta G. And what is exactly equal to? It's equal to this value, which is, by the way, the key to this fact, the key to the fact that the increase in Y will be greater to the increase in G is that the slope of the planned expenditure line is less than 1. The marginal propensity to consume is less than 1. And this is why, you see here, this value in the denominator will be lower than 1. And so the whole thing, 1 over 1 minus MPC, will be greater than 1. So therefore delta Y will be greater than delta G. Okay, how do we know that this is the increase in Y following an increase in G? We can find it out through just a little bit of algebra. There isn't much algebra in this course, but this is one case where you see a little bit of algebra. So this is the original equation of actual expenditure, Y equal planned expenditure, C plus I plus G. So then we look at, so naturally, the change in Y will be equal to the sum of the changes in the three components on the right side, right? Now, investment is not affected, so this delta Y is equal to 0. Delta Y is 0. There is no change in Y. I. I is not changing. What is changing is delta G, because we are changing it exogenously, and delta C, because C is a function of Y. Okay? So, these are the two changes, relevant changes. So, delta Y is equal to delta C plus delta G. Right? But delta C is equal to, as we said, the fraction of the change in Y that occurred. So it's MPC, the marginal propensity to consume, times delta Y. So now we have an equation with delta Y on both sides. You see that delta Y equal MPC times delta Y plus delta G. So we need to solve that equation for delta Y. Do you know how to do that? All of you? We move the term in delta Y on the left. Okay? So that's what we have. And then all we have to do is isolate delta Y by dividing through by 1 minus MPC, and we get the expression with this term being the multiplier, the government expenditure multiplier, which is greater than 1, because MPC is less than 1. Okay? Any questions so far? I feel I'm going a bit fast because you have no questions, but believe me, it seems all nice, clear and plain. When it comes to it, people start making mistakes. They shift lines when they should be moving on the line. They mistake, changes one way for changes the other way. So make sure you understand what is going on. Yes, you had a question?
So how did you get C is equal to MPC delta Y, delta C?
So we said that C is equal to, C is a function of disposable income, Y minus T. Okay? So here T is not changing. So delta T is equal to 0. Only Y is changing. So it's C is equal to MPC delta Y here, delta C. Okay. Since C is equal to MPC Y minus T. Okay, let me start from the beginning. C is equal MPC Y minus T. Okay, so delta C is equal MPC delta Y minus MPC delta T. But delta T is equal to 0, so this term is not relevant. So we are left with MPC delta Y. Okay. So next we consider an increase in, before considering the increase in taxes, let's see how it works the other way, with the other graph, with the savings equal investment graph. Okay. So here, what happens when we increase G? Again, this is now the relevant equation. So if we increase G, what happens to the savings?
Savings reduce.
Go down, right? We are increasing basically public consumption, so savings go down. So the saving line at each interest rate shifts to the left. When we increase G, the saving line shifts to the left. Okay? So if we started at 6% interest rate, E, okay, we are here with this level of income, then once we increase G, savings move left. So at the original interest rate, there is now excess demand for funds. The amount of investment is larger than the amount being saved. So the interest rate will be driven up and will move to 7% to F. All this happens at the same level of income now. These two lines, see what is sometimes a bit confusing for students, is that here the shift, when there is the shift, there is no change in income. In the previous case, when we were, deriving this one, when the line was shifting was because of higher income. So these two lines are at two different levels of income. Here the two lines, they are drawn at the same level of income. Oops. Same level of income. So we are still at the same level of income, and that's why we change curve, and the curve shifts up or to the right. Okay? So this is how we analyze the shift in this context, with the saving equal investment graph. Now the next step is to consider an increase in taxes. Again, first let's do it with the Keynesian cross. So that's planned expenditures. Now what happens when we increase taxes?
Oh, shifts downwards.
You see, this is C1. It's a given level of consumption, which is a function of disposable income, income after taxes. Now, if we increase taxes, that level of income, disposable income, goes down. Okay? So, the planned expenditure goes down because consumption also goes down. And the magnitude of the shift is exactly minus MPC times delta t. You see now this term is no longer 0. This one is now at work, this term here. It's no longer 0. Okay? So, but of course, delta g is now 0. So what we have is, first, due to the shift at the original level of income, there is unplanned accumulation of inventory. So income goes down, and to a lower level. Okay? So we have a delta y. But the interest rate did not change. So this is why we shift to another IS curve. This is the algebra behind it. Okay? So now the only thing that is positive is delta C. Both this and this are 0. Okay? So delta C is equal to this. So we have this equation. And again we have to solve this equation for delta y. When we do that, now this is the multiplier, which is less than the one concerning government expenditures. Because now we have, instead of 1, we have MPC here. Okay? So you see here, the vertical shift before, in case of delta G, was the entire delta G. Here it is not the entire delta T, but it's MPC times delta T. That is why the multiplier is smaller. Okay. Any questions so far? Is everything clear? Yes?
The change in y we did before, change in y equals to 1 over 1 minus MPC multiplied by change in g. That is also a multiplier?
That is a multiplier for G. So that's called the government expenditure multiplier. This one. This is the government expenditure multiplier. The other one is the tax multiplier, which is lower. This one is smaller than the government expenditure multiplier because of the fact that we don't have the original change as delta T, but it's now MPC times delta T. All right, so this is what I wanted to cover with respect to the IS curve. No, there is still one thing left, which is the same thing when we look at the S equal I graph. Okay? So here, we have an increase in taxes, which will shift the IS curve to the left instead of to the right. In case of increase in G, it was shifting to the right. In case of increase in taxes, it shifts to the left. Why? Because again, the increase in taxes reduces C, reduces C. So what happens to savings? Increase. So savings increase, so the saving line, it's not here, but the saving line will shift to the right, outwards. And so we have exactly the opposite of what was happening with the increase in G. Okay? Instead of shifting left, the saving line shifts right. So the IS curve, instead of shifting right, it will shift left. It's exactly the opposite of what we had in the previous graph. Okay. So before we move on to the LM curve, let's summarize. First of all, we saw that there is a downward sloping aspect of the IS curve. So whenever interest rate goes up, to keep the goods market in equilibrium, we need a decrease in output. And also we saw that any exogenous change other than, those that are on the axis, other than interest rates and output, that will shift the IS curve. Okay? So here it's a summary table which gives you all the reasons why the IS curve might shift, all the exogenous reasons. So we have seen two, government purchases and taxes. The reason why we focused on these two is because these are generally policy tools. They are the tools which the government uses to steer the economy. So the others are more like truly exogenous and coming from different reasons. So we may have an increase in wealth, an increase in expected future output, or even an increase in the marginal future marginal product of capital, etc. All this will, for example, an increase in wealth, of course, will shift the IS curve to the right. Because once you have more wealth, you consume more. So you save less. So it's the same story with the increase in G. The same mechanism that is at work. Okay? And the same goes for expected future output. Okay. So this is a summary of with respect to the IS curve. Before we move on to the LM curve, let's take a short break. It looks like a very natural point to break. And then we look at the LM curve after the break.